Divisha,
Yes, ma'am.
you can start now.
Yeah, okay, ma'am. Good morning, everyone. It is my pleasure to introduce our esteemed guest speaker, Dr. J. Vanilla ma'am, who brings with her an impressive academic and professional background in the field of statistics. Ma'am holds a PhD in statistical quality control from Bharatiyar University, Coimbatore, earned in 2020. Following her MPhil in statistics from Periyar University, Salem in 2009, and her MSc and BSc in statistics from Bharatiyar University in 2006 and 2004, respectively. With 15 years of experience in teaching and research, Vanilla Ma'am has made significant contributions to the academic community. She has also taken on various administrative roles, including Deputy Management Representative for ISO certification, NAAC, Department Coordinator, and NBA Criterion in charge. She has served as a key member of the Institute Research Committee and contributed to TCS ION and SWAYAM initiatives. In addition to her administrative expertise, Ma'am has been actively involved in presenting papers at national level seminars and conferences, with 15 presentations to her credit. She has participated in over 80 faculty development programs and workshops, demonstrating her commitment to continuous learning and professional development. Today, we are honored to have her with us to share her knowledge on exploring data analytics using statistical methods. Let's extend a warm welcome to Dr. J. Vanilla ma'am. We welcome you, ma'am. Now, the session is all yours, ma'am.
Thank you, Pangudi ma'am, and thank you, Divisha, for this one. And Pangudi ma'am, thank you for giving this opportunity. Uh, can I start the class, ma'am?
Ma'am.
Okay, ma'am. Students, good morning to everyone. Today we are going to discuss. Uh, Today we are going to discuss the important Unit 4 topics. The first one is a normal distribution, second one is a correlation, and third one is a regression analysis. Okay, so these 3 points, important points, we are going to discuss today. So we will discuss one by one. First, we take the topic normal distribution. What is mean by normal distribution? Before going to the normal distribution, did you study the probability concept? What is mean by probability? Anyone? What is mean by probability? Students, what is mean by probability? Okay, probability means getting a chance. Okay, for example, if you have a coin is there, if you are tossing a coin, if we get head or tail, it is called as a chance, getting a chance. So from that, we are observed that we need one event and success rate and failure rate is needed. So that is a probability concept. Probably mean getting a chance. Okay, so success rate and failure rate is there in the probability. So we can consider 50% is success and 50% is failure. So the total probability is 1. The range of probability is 0 to 1. So when you have only one coin is there, that means only one event is there, that time we have to apply the probability concept. Okay, when the number of trials are increasing, for example, you have a second one and third one, so number of coins simultaneously when you are tossing, so like the situation we have to use this a normal distribution. Okay, so first we are going to discuss with the binomial distribution. What is mean by binomial distribution? I don't know, number of trials is increases, so probability formula is nothing but n of a by n of s. Okay, n of a by n of s. N of A means, for example, to one coin I am tossing, okay, head and tail is there. So total sample space, how many chances there? Two chances there. Either I will get head or either I will get tail. So that is a sample space 2. But I will get only one result. So that is a N of A, the number of favorable chances divided by total number of the opportunities is called as a answer for tossing a coin. So that is a P of A is equal to 1 by 2. So this is when we have to apply. I have only one event is there. So like the situation, I have to apply this concept. But the number of events are increasing. Okay, so that time they are developed. James Bernoulli was developed the Bernoulli distribution or binomial distribution based on the concept of number of trial, success rate and success failure. So in the probability we don't have any parameters, but James Bernoulli considered as these points or as a parameters and he developed binomial distribution. Okay, this is a basic fundamental distribution of probability distribution. So once you derived the binomial distribution, okay, here success rate and failure rate is equal to 1. Okay, that means success is 0.5, failure is 0.5. I don't know the range of the probability. So based on that, here they are considering that NP. So they are giving more important for NP because success rate, if you know, automatically we can find the failure rate. So that is a understandable. So they are taking from this one N and P as an important variable. From the binomial distribution, they are considered N and P is a important variable. After that, they are applying the limit case N tends to infinity and P tends to infinity, or the very large or small values they are applying. So when they are applying these things, it is automatically converted into the normal distribution. Okay, so the small and easiest definition is the limiting case of binomial distribution is called as a normal distribution. Okay, so that is a normal distribution definition. Okay, so when we are applying n tends to infinity, n is called as a number of trial. So n tends to infinity and p tends to infinity. This is automatically converted. Binomial distribution is automatically converted into the normal distribution. Okay, so what is the definition of normal distribution? The limiting case of binomial distribution is called as a normal distribution. This is a formula, okay. This is a formula for normal distribution. F of x is equal to 1 by root pi into sigma into e power minus x by mu divided by the 2 sigma the whole square. Okay, this is a formula. Now Laplace and transforms. Okay, Laplace was found out this normal distribution. Once he found that, he again applying the limit mean. See here, mu means mean. Okay, mu means mean. Okay, so based on this formula, again they are applying some limits. Sigma means standard deviation. So based on this concept, they are using mu is equal to 0 and variance is equal to, variance means sigma square. Sigma square is equal to 1. So when they will apply these things, okay, mu is equal to 0 and sigma square is equal to 1, it is converted into z square. That means that formula is x minus mu by sigma follows normal distribution of, normal distribution means large sample size. So normal distribution of 0, 1. So when they are applying mu is equal to 0 and variance is equal to 1, the normal distribution term is converted into the standard normal variate. I hope you are clear this. What is meant by normal distribution? The limiting case of binomial distribution is a normal distribution. What kind of limit they are used? n, number of trial tends to infinity, and success rate p tends to nearby very small, or infinity is considered as a normal distribution. Okay, so the normal distribution formula is this one. Okay, based on the normal distribution, we have to apply the concept mean mu is equal to 0 and variance sigma square is equal to 1. So it is converted into the standard normal variate. Okay, so this is the first one. Okay. After finding that, we want to study about the properties of normal distribution. This is the most important one. You just listen this graph. Okay. You just listen this graph. These are the things we have to say, the properties. What is the shape of? First you can look in the shape. What is the shape of the distribution? The shape of the distribution is called as a bell shape. Okay, see that it's a bell shape. Okay, and second one, see this 0 to infinity and 0 to minus infinity. Okay, so the range of normal distribution is minus infinity to plus infinity. So the second property is the range of normal distribution is minus infinity to plus infinity. That is the second one. Okay, and third one, you can see that minus infinity to 0. Okay, minus infinity to 0 and 0 to plus infinity. You just see these two things, both are equal. Okay, both are equal. That means what they are telling, the minus infinity to 0 is 0.5. That is a 50% failure, and 0 to plus infinity is a 50% of the success rate. It's a positive side and negative side. So 0.5, 0.5. So it is equally divided on the both side. So it is called as a symmetrical distribution. So normal distribution is a symmetrical distribution. That is a third properties. And see the fourth property. See that x-axis, and when we are drawing the y-axis, some gap is always there, because based on the variance only we are studying, right? So always this gap is there. So it is called as a asymptotic curve. It is called as a asymptotic curve. Now, when and which situation we have to use this normal distribution? When you have to calculate mean median mode. Mean means the set of value represent in a single term. Median means what? The middlemost value is called as a median. Mode means the repeated value is called as a mode. That is there in basic statistical method, measures of central tendency. I hope you are understand what is mean median mode in previously. Okay, so when you are calculating the mean median mode, the three values are equal. Okay, for example, mean is 10, median is 10, mode is 10. So when you are calculating, these three values are same, that time only we have to apply the normal distribution. Okay, and see, this is a standard normal variate line. The center line is called as a standard normal variate. Here we will get only one peak value. Okay, so p of x, that is called as a only one mode. Okay, only one highest value is there in normal distribution, so it is called as a unimode. Okay, so it is called as a unimode. Okay, these are the some of the properties of normal distribution. Okay, and most important one, what is the reason we are studying this? Okay, area under curve. Once you understand this, then you can easily understand why we are studying the normal distribution. Okay, this concept you just remember. The first one is mean plus or minus 1 sigma. The second concept is mean plus or minus 2 sigma. And third concept is mean plus or minus 3 sigma. You just always remember this because you are a MCA students, right? So this method is always we are going to use to increase the quality level. Okay, quality level is important. Okay, for example, you are going to manufacturing some products. Okay, so that time your production line, if you are there, means you have to check 2 times the quality is good or not, then only customers will buy your products, yes or no. For example, okay, you are manufacturing some particular program, okay, you are developing a program or you are giving to your buyers, so that time they will think many errors are there, means definitely they will not buy your program. Okay, they will say many errors are there in this program, how can we use this program, they will ask. So like that time we want to reduce the errors. Okay, so that is called, that is the reason we are using this mean plus or minus 1 sigma. In graphically we can represent this area, negative side is called as a mu minus 1 sigma, positive see we can, let us consider this is a mu plus 1 sigma. Okay, if you are using the concept of mu plus or minus 1 sigma, we are going to accept only this part, that means 68% only you are going to accept. Okay, 68% only you are going to accept. That means what, when you are manufacturing some items with help of the mu plus or minus 1 sigma concept, your manufacturing goods are only 68% is good. Okay, the remaining items or remaining percentage are defective items. Okay, so that is the meaning. Okay, let us consider this part. This part is mu minus 2 sigma, and here also you can consider mu plus 2 sigma. Okay, if you are consider these points or mu plus or minus 2 sigma, means this area you are going to accept. That means 95% you are accepted the good qualities. Okay, manufacturing the good quality, remaining only 5% defective is there. Okay, so quality is increased. Okay, so when you are using mu plus or minus 3 sigma, okay, let us consider this is minus mu sigma, and here you have to consider mu plus 3 sigma. Now if you, okay, you just share this areas. Okay, if you are using mu plus or minus 3 sigma, okay, 99.97% you are manufacturing very good products, parts per million only you are manufacturing defective items, that much quality is there in your item. Okay, so that is the meaning for that. So why we are studying normal distribution, we want to improve the quality of the data set. For example, medical field means they have to use the data set, patient informations or correct or not, so with quality or not quality, that is the reason they are using. In a computer purpose, what accuracy they want to identify, precision they want to identify, means that time they have to use normal distribution. Manufacturing side, the product they want to check it is whether it is good quality or not, that is the reason they are using the normal distribution. Okay, so this is the reason they are using the normal distribution. We just go through this. What are the points we have discussed previous, that is there, it is the bell shape. Okay, that top value p of x is there, both sides are equal, the range of probability is there, the x and y value will never touch, that is asymptotic, we have only one mode is there, that is unimode, and the parameter obviously it is mu and sigma, that you know that. Okay, this point I forgot to see. But when you are taking a mu plus or minus 68%, mu plus or minus 2 sigma, that is 95%, and mu plus or minus 3 sigma, that is 99.97. Now in manufacturing side they are using 6 sigma concept, that is mu plus or minus 6 sigma. Nowadays they are using, what is mean by mu plus or minus 1 sigma, means zero defects, that means 100% the manufacturing companies are producing the good quality. Okay, so that is a concept they are using this mu plus or minus 1 sigma, but this is not applicable for developing countries. Okay, you know very well why. Okay, so developed countries are using this concept, but till now in India, every expert the medical sorry expert that Mhm. Uh, this field, manufacturing field, the remaining fields are using only for mu plus or minus 1 sigma. Till now, we are not used 2 sigma and 3 sigma and all. Only manufacturing companies only they are using to improving the quality purpose mu plus or minus 6 sigma. But till now, we are using only mu plus sigma concept. I hope you are clear. Any doubt is there? Students, any doubt is there? The normal distribution?
No, ma'am.
Okay. Okay. Now we have to discuss the problems of normal distribution. Okay. Problems of normal distribution. Before going to that, okay, you just download the normal distribution table. Okay. One second. I will open the table. Okay, first I will explain the problem, then we'll go for a this one. First problem, probability of x less than 1. Okay, so the first problem, find the normal curve. Okay, find the normal curve for probability of probability of z less than 1. Okay, for this problem first you can draw the normal curve. Okay, first you can draw the normal curve, and this is a standard normal curve. This is a range of minus infinity to plus infinity. Okay, this is a bell shaped curve. What is our problem here? Z is equal to 0. Okay, once you properly draw the diagram, you just listen the look the problem. Okay, what is the problem? Probability of z less than 1. This 1 is a positive value. Positive value will come in between of the 0 to plus infinity. Let us assume here is a 1. Okay, then draw the line. I hope you are clear. Probability of z less than 1. Okay. First you can draw the line. Then you have to check that value is positive side or negative side. So based on that you have to draw the line. Now what is the concept? Probability of z less than 1. Less than 1 will come which area? That this side or this side? Which side it will come? Anyone? Which side it will come? Probability of z less than 1. Less than 1 means what? 0 0.9, 0 0.8, 0 0.6, 0 0.5 like that. So it lies on this side. It is lies on this side. Okay. It is lies on this side. This area you have to share. Okay. Up to 1 you have to share. Up to 1 you can share. Okay, now the area you are done. Okay, so area is what? Probability of z less than 1. Whenever you have this one, okay, you can take only the table value. It's a short one. Okay, it's a easily you want to understand means you have to think. If you have, whenever you have to symbol less than, you can use only table value. Okay, now we have to check how we can identify the table value. Okay, I hope you are clear this. Okay, now you can see this table. Is it visible, mom? The table is visible.
No, ma'am.
Yes, ma'am.
Yeah, it's
Yes,
visible, right?
now it is visible, ma'am.
Okay. Now, what is the value we got? Z less than 1, right? Less than 1. So, you just take the two types is there, okay? Standard normal curve. We have a two side is there, okay? This is called as a negative term, okay? Left side. And this is a positive term, okay? So, two table, left side table and right side table. Less than left side table, it start with a minus 3. See here, it is start with a minus 3, end with 0. And right side table, it start with 0 and end with 3. If more than 3 means, you can take that table also, but our concept is mu plus or minus 3 sigma. That is the reason you have to consider only minus 3 to plus 3. Now, what is our value? Our value is 1. Okay, 1. You just check 1.000. What is the table value? 0.8413. Okay, our value is 1. 1 means we have to consider with the decimal point 1.00. So 1.0 you can take this side, and 0.0 you can take the column side, and you have to take the corresponding value from the table. So the corresponding value is what? 0.8413. So your answer is 0.8413 is your answer. 0.8413 is your answer. That means 80 percentage possibility is there for accepting the particular area. Okay, 84 percentage possibility is there for accepting probability of Z less than 1 area. Are you clear, ma? Any doubt? Are you clear?
Yes, ma'am.
Okay. Now we can go for the second one. Probability of Z greater than 1. I am taking the same problem, but the symbol is changed, greater than 1. Okay. So probability of greater than 1 is nothing but, so first I will explain with the diagram. Okay, first you can draw the diagram. Okay, sorry. Now you just draw the diagram. Z is equal to 0, minus infinity to plus infinity. Then assume the same place is equal to 1. Okay. Now it is a greater than 1, right? So 1, 2, sorry, greater than 1. So 2, 3, 4, 5, 6 up to infinity it will go. So we can share this area. Okay, we can share this area as a under curve. Okay, so when you have like this term, you just take 1 minus probability of Z less than 1. Okay, sometimes you will not remember this formula. Okay, so that time you have to remember 1 minus table value. 1 minus table value, you just remember. What is mean by 1? 1 is a total probability. Okay, maximum probability is 1. So we know that this total probability, the total curve value is 1. So from 1 we are subtracting only this area. Sorry. We are subtracting only this area. Okay, then we'll get this area answer. So total area minus this area means we will get this area answer. So that is equal to 1 minus table value. So we know that the previous problem we have solved that. What is the table value? 1 minus 0.8414 is a table value. Okay, so probability of z less than 1, previous problem we have solved, then we are identified from the table. Okay, it is 0.8413. Sorry, 8413. Okay, you just subtract this one, and what is the answer? 0.1487, right? Check that one. You can calculate 1 minus 0.8413. What is the answer? 0.1587. 1587. 1587. That means 58 percentage 0.87. 15 percentage we have a chance for accepting the particular area. Okay, so this area possibility is there only 15.87 percentage. Okay, I hope you all understand this. Any doubt you can ask me, ma. Any doubt? Students, any doubt?
Oh, ma'am.
Okay, then we can go for third problem. Probability of probability of minus 1 less than z less than plus 1. This is a third problem. Probability of minus 1 less than z less than plus 1. Okay, you just first you can see this is starting with minus 1 and ending with plus 2. And ending with plus 2. Okay, I'll change the problem. Now first you can draw the diagram, then fix the limits. Minus infinity is equal to 0 and plus infinity. Now it is starting with the minus 1, right? So let us assume this is a minus 1 and ending with the plus 2. Then let us assume this is a plus 2. So we want to identify this area. How many percentage possibility is there accepting this area? Are you clear, ma? This area only we need to find. Okay. Now carefully you have to listen that minus infinity into 0 is there. From that we want to identify only minus 1 to 0. Again the second point 0 to plus infinity is there, but we want to identify only 0 to 2. So this part in mathematically, how can we write probability of starting with the minus 1, okay, and end with 0. And again it's starting with 1 starting with 0 and ending with the +2. Okay, so mathematically we can write it's starting with the -1 and ending with the 0. Again, it's starting with the 0 and ending with the +2. So this is a concept mathematically we have to write. Now, is equal to. You can see this. What is the term? It is starting with the minus infinity generally and ending with the 0. So that value is what? 50%, right? So 0.5. Okay, then this is a within term. Okay, this area is called as, okay, if you want to find out within this area, it is called as a within. So we can put minus symbol. Then what is this? -1 to 0? What is the answer? -1 to 0. Now again you can go to the table and you can check minus side, left side table, and what is the 0 minus 1, 0.00 value. So what is the table value? 0.1587. Okay, the value is 0.1587. So just take that value 0.1587. Okay, then it's over. This part is over now. Okay, are you clear? So whole term we are subtracting only this area. Now plus again. What is that? 0 less than z less than 2. So first we need to find out the table value. Okay, 0 less than z less than 2. So what is the table value of 2? Just go to the table and it is a +2, right? Positive side. So take the right table. Okay, sorry. Take the right table. 2.00, the table value is 0.9772. Okay, 0.9772. 0.9772 minus. Okay, so minus. Okay, so this area value we are identified, right? This area value we are identified. So what the whole term? 0.5. 0.5. So the whole term minus this area and plus this area plus whole term. This is a concept. Okay. Now you can subtract these two things and simplify and tell me the final answer. 0.5 minus 0.1587 table values 0.3413 plus 0.9772 minus 0.5, we will get a 0.4772. Then you can add these two things, we will get 0.8185. That means we have a possibility is there, 81% the possibility is there for accepting the particular area. That is a meaning for that. Any doubt is there for this tips, ma?
No, ma'am.
Okay. Okay, these are the probability problem. This is called as a direct problem. Okay, the next one is an indirect problem. What is mean by indirect problem? Now you just listen this. Okay, I will explain only the first step. The second steps and all you have to solve. Okay, okay. For example, they are given once again. This word file is visible, ma'am? The word file is visible?
Ma'am.
Yes, ma'am.
Okay, ma'am. Okay, listen the first one. If normally distributed with the mean 12 and standard deviation 4. So mean means mu is equal to 12. Okay, and standard deviation is equal to 4. Okay, this is an indirect problem. You can see this is a board problem. So when they will give like this way, we have to consider this is a indirect model. Okay, and one more thing you just see here, they have mentioned in the problem x. X means random variable. Okay, whenever x is there, we cannot possible to calculate that. We need to convert into the z term. That is important. Okay, so mu is equal to 12, sigma is equal to 4. Okay, now first what is the concept? First I will take this problem. Okay, first I will take that problem only. So then first problem is what? Probability of 0 less than x less than or equal to 12. Okay, so I want to use the formula here. What is the standard normal variate problem? X I want to convert it into z. So z, what is the z formula? X minus mu by sigma. Here two x values they are given. This is 0, we can consider x1, 12 we can consider x2. So x1 less than x1 minus mu by sigma less than z. Now x is converted into z. Then less than x2 minus mu by sigma. Okay. After that, you have to convert this into probability of, substitute the value. What is the x1 value? 0 minus, what is the mu value? 12. And standard deviation value is 4. Less than z, less than, what is the x2 value? 12. Okay, 12 minus mu value also 12 divided by, what is the sigma value? 4. That's all. If you substituted that things means, we'll get that, we get the answer. See here. So we will get probability of minus 12 by 4 is what? Minus 3, right? Minus 3 less than z less than 0. We get this one. Okay, so the indirect problem is converted into the direct model. So previous problem how we solved, no? So like that way you can solve that. Okay, so before that we want to take care of the few steps. That's all. Okay, so the random variable concept we are converted into z score. Random variable is possible to get what are the values is, but whenever that we are converted into z score, it's starting with the minus 4 and ending with the plus 3. That's all. It will not go beyond that. Okay, you just always remember. So if it is getting more than 3, means it is not a z score table term. Okay, then you have to carefully relook it in that problem and you have to solve that. Okay, I hope you understand the first options, right? After this, you have to solve the problem. Based on this, you have to solve the problem. Okay. I hope you understand the normal distribution and problems. Okay. Next, we can go to the next important topic in our thing, correlation. What is mean by correlation? Normal distribution is we are finding quality level purpose. Okay. When you want to find out the quality improvement, that time we are using the normal distribution. Now we are we are going to study the new topic of correlation. Correlation also one of the methods of descriptive statistics. Okay, you know that what is mean by descriptive statistics? The summarize of the data set, data frame is called as a descriptive statistics. Okay, the correlation is one of the method. What is the meaning for correlation? When you have a two variables are there, okay, when you have a two variables or more than two variables, if you want to find out the relationship between the two variables, both are going to the same direction or opposite direction. If you want to identify, that time we have to use the correlation. Okay, for example, I'm tell you one medical example. Okay, you are giving some drugs. Okay, and you are giving some therapy also for that patient. So that time you want to identify the drug is properly working or any drugs and therapy. If you have any relationship is there or not. If you want to find out, that time we have to apply the correlation. Otherwise you can take the college students. Okay, I want to identify the patient's obesity informations. Okay, so that time I have to take the students height and weight. Okay, height and weight is proper, the BMI isn't normal. Okay, the height and weight is not mismatched means it is go to either underweight or obesity, right? So I want to check height and weight for the each and every patient is going to the proper, it is a normal or not, I want to identify. So like that situation I have to use this correlation. Okay, then the correlation ranges -1 to +1. You just always remember probability range is 0 to 1, correlation range is -1 to +1. Okay, after that we want to find out what is mean by coefficient of correlation. Okay, the degree to which the two variables interrelated. Okay, interrelability is there. Okay, when you are measured by the coefficient, it is called as a coefficient of correlation. Okay, so what are the properties are there in a correlation? The important four properties only I mentioned here. You need two variables. Your data must be quantitative or qualitative. Okay, your data must be quantitative, continuous, and when you have a two related variable, okay, then it's possible. Okay, the second one, the range of correlation is starting with -1 and ending with +1. Okay, and third one, okay, if you get exactly r is equal to 0, there is no relationship between the two variables. And the last one, when you get exactly r is equal to -1, it is called as a perfect negative correlation. In case if you get r is equal to exactly +1, it is called as a perfect positive correlation. Okay, after that in the study we want to inform the two things. Okay, one is a univariate distribution and another one is a bivariate distribution. When you have only one variable is there, okay, so that time we cannot possible to apply the probability. So that's the reason you just understand, when you have only one variable is there, it's not possible to apply the correlations. That is called as a univariate distribution. When you have a two variables are there like height and weight, like that way, so that is called as a bivariate distribution. That time only is possible to apply the correlation. Okay, then based on the correlation coefficient, we have to study the covariance. What is mean by covariance? We have a two variables there, right? X variable and Y variable. So X variable and Y variable, you want to identify how many set of the variables are corresponding to the particular two things. If you identify that, it is called as a covariance of X and Y. Okay, so these are the important definitions of correlation. The next heading we are going to study the types of correlation. What are the types of correlation? Mainly we are going to study three types of correlation. One is positive correlation and another one is a negative correlation. If you have a X and Y value, okay, X is a one variable, Y is a one variable. X value is increasing, okay, 10, 20, 30, 40. Gradually it is increasing. Okay, and y value also like that, 10, 15, 22, 26. See here, both are gradually increasing, x value and y value. When you draw like this and all, we can get a straight line. Okay, we will get straight line and it will slightly increase, not decrease. Okay, you can see it's a linear curve. So when you will get perfect linear curve, that time it is called as a positive correlation. Okay, then the same thing you have to take. Okay, the same thing you have to take. One is going to increase and another one is going to decrease. 3, 2. See, for example, x value is gradually increasing. So one value is increasing, another variable is decreasing. So like this situation, it is called as a negative correlation. That means the values are moved to upwards to downwards. You just see that both are linear. Both are linear, but you just check the lines how to it's moving. The values are downwards to upwards, it's moving with a straight line, means it is called as a positive correlation. Okay, when the data are moved upwards to downwards with a straight line, it is called as a negative correlation. Okay, so that is the meaning of positive and negative correlation. And the next one is a simple partial and multiple correlation. When you have two variables, you have only two variables, x and y. When you have only two variables, that time we have to say that is a simple correlation. Okay, when I have a more than two variables, okay, when I have a more than two variables, that time I have to say multiple correlation. What is meant by partial correlation? I have a three variables are there. I have a more than two variable, but I want to find out only that only the relationship between the partial. I don't want this three totally. So like that, I have to say. You remember 1, 2, 3, 2, 3, 1. 3, 2, 1. You just remember this, right? So 3, 2, okay, 2, 3, 1, 3, 2, 1. Okay, sorry. 3, 1, 2. Okay, so like the term, we have to find out only these three variable. Okay, 1, 2, 3 I have, but I am giving important for the first 1 by 2. Partially I am doing. Third one I am not considering. The second I am taking 2, 3. 1 I am not considering. Third one, 3, 1 I am considering. Second one I removing from my. I am not considered in my study. So like this term is called as a partial correlation. So when you have a two variable, it is a simple correlation. More than two variable is called as a multiple correlation. So when I have a more than two variable, but I am considering only the pairs. So like that term, it is called as a partial correlation. Okay, and third one is a linear and non-linear correlation. You know the meaning of what is a linear and non-linear. Y is equal to a plus bx is called as a linear. So when you are drawing the curve, okay, so it is a straight line, means it is called as a linear. So y is equal to x square or quadratic, cubic, hyperbolic, everything is comes under the non-linear curve. Okay, so that is the meaning for this linear and non-linear. Okay, the next one is measures. What are the measures are there? How can we calculate the correlation? So totally we have a three methods is there for using to calculate the correlation. One is a scatter diagram, second one called Pearson, third one rank correlation. In graphical method, you want to find out the correlation means that is called as a scatter diagram. Okay, I don't want any value. I don't want any value. Okay, I want only diagram. Based on the diagram, I want to identify how the relationship is there between the two variables. So that time I have to use the scatter diagram. Okay, so these two are called as a algebraic method. Okay, we have a formula is there. Based on that, we have to calculate. Okay, both are as a algebraic model. But what is the purpose? Okay, both are algebraic method. Then what is the reason we are studying the two models? Because one, the second one is there. No, when your data are quantitative, when your data are continuous, when your data are normally distributed, so these three conditions are satisfied, then it's possible to apply the Call Pearson coefficient. For example, patient bp, okay, patient bp or heart rate if you are taking, okay, bp level and heart rate if you are consider means bp level and heart rate are continuous data, okay, and quantitative, then we have to check whether it is normally distributed or not. So the third condition, we have to use some concept, then we have to identify whether the data set is normally distributed or not. So that condition also satisfied, then only possible to apply the Call Pearson coefficient. Okay, now I have only score, pain score. Is it possible to identify the pain? How much pain you have? What we have to say? Yeah, I have a mild only there. So sometimes I have a severe pain is there. I can't to tolerate, like that way we can say that is a qualitative data. Are you clear? That is a qualitative data. So we are understand. Okay, the patient having a less pain. So we can consider that is 2 marks. I will ask. Okay, out of 10. Can you tell me your pain score? They will say only 2. Sometimes if I'm asking to other patient, can you tell me how much pain you have? They are telling I have a moderate. Then I'll say, can you tell me the score of 4 to 7? They are telling 5. So then I consider 5 as a score. So like that is there. That is called as a qualitative data. So when my data is qualitative, okay, that means scores, then my data is not normally distributed, then I have to use the Spearman correlation. Okay, the situations are different. Okay, so when my data are quantitative, continuous, normally distributed, I have to apply the Call Pearson model. When my data are qualitative and it is like a score or rank, but it is not normally distribution, like the situation and all, I have to apply the Spearman rank correlation. So this is the difference between these three models. Okay, so three models are there. Three models we have to apply in a three different situations. Okay, once again I will tell you, I don't want to calculate anything, I want to show only the diagram. So like the situation, I have to apply the scatter diagram. Okay, I have a data set is there, it is a quantitative, that is a real data. So that time I have to check whether the data are normally distributed, then I have to use the Call Pearson model. My data is everything is correct but not normally distributed, or my data is qualitative, like the situation, I have to apply the Spearman rank correlation. Now you can check, see this diagram. Okay, see this diagram. First diagram, okay, figure 1 is called as a perfect positive correlation. So when you get exactly r is equal to +1. Okay, before that I'll tell you one. Okay, you just remember, then will easily you will understand this. What is the range of correlation? What is the range of correlation? -1 to +1 is a range of correlation. This they are classified into 5 types. Okay, this is they are classified into 5 types. Just listen that, just see this range. Okay, what is the -1? Okay, if I get exactly -1, what will happen? So this range is -1, Center is always 0 and plus 1. So if I get exactly minus 1, okay, it's a perfectly perfectly negative correlation. Okay, it is called as a perfectly negative correlation. In case if I get exactly 0, that is called as a no correlation. There is no relationship. 0 means not valid. Okay, and if I get r is equal to exactly plus 1, okay, so that is called as a perfect positive correlation. Okay, positive one. In case if I get the answer r is equal to minus 0.68, it is in between of 0, minus 1 to 0, right? It is in between of minus 1 to 0. So like this situation, it is called as a highly negative correlation. In case if I get the answer 0. Plus 0.98 plus 0.98, it is lies in between of the 0 to plus 1. So like the situation, I have to call this as a highly positive correlation. So when you solve the problem, we must to see this thing. What is your answer? So based on the answer, you have to write the conclusion or you can use the command. These two things are have highly and strongly correlation is there. Sorry, you just see many manuscript, they have to mention the word highly correlated, strongly relationship is there between the two variables and all. So based on this only they have to say that. So in graphically, how can we identify that when you are drawing the curve, okay, x-axis and y-axis you have, okay, when you drawing the curve lines are moved to downwards to upwards with a straight line. It is called as a perfect positive correlation. The same thing when you draw the line, okay, when you draw the line, the lines are moved to upwards to downwards with the linear function. Okay, with the linear function, it is called as a perfect negative correlation, that is r is equal to minus 1. Okay, if I get answer 0.65 plus 0.65, it is in between of r is 0 to plus 1. So like the term, I don't get any linear. Okay, this is a non-linear line. Non-linear means I will get like this. Okay, so non-linear type if I will get means that is called as a highly positive correlation. The same concept when you drawing, it's moving upwards to downwards with a non-linear function. It is called as a highly negative correlation. I am not getting a proper diagram. Okay, when I am joining, I am getting like this. I am not getting a proper diagram. I can't to identify whether it is a linear or non-linear. Or when I am calculating, I am getting exactly r is equal to 0. Or sometimes I am getting r is equal to 0.0005. Like this situation and all, we have to say this is called as a no correlation. So when you are having a two variable, you can carefully check whether it comes under which concept, and based on that you can write the command. Okay, I hope you understand. Okay, next one is a Cole-Pearson model. That is the previous one is a graphical representation. This is a Cole-Pearson model. Cole-Pearson is also used to find out the relationship between the two variables. The definition is same. Correlation, Cole-Pearson, Spearman correlations definitions are same. Only situation is different. That is previous I explained. No, this is a basic formula of correlation. We have a two formulas is there. Okay. Either one formula you have to use. This is a one formula. Another formula is this one. Summation xy minus summation x into summation y divided by first root of n into summation x square minus summation x the whole square You just remove f from the above problem, that's all. That is the second one. Root of n into summation y square minus summation y the whole square. That's all. If you remove f, okay, if you remove f, that is the second formula. That's all. Okay, if you remove f, that is the second form. Okay. The next one is Spearman rank correlation. Spearman rank correlation also, you know that when your data are not normally distributed, then only we can apply. Not normally distribution is called as a non-parametric test. Okay, not normally distributed is called as a non-parametric test. So when you have like that term, we have to use this formula. Rs is equal to 1 minus 6 into summation di divided by n into n square minus 1. Di is nothing but the difference between the rank 1 and rank 2. Di is nothing but the difference between the rank 1 and rank 2. Okay, so this is a formula for correlation. Spearman rank correlation. Okay, I hope you understand the correlation concept. Do you have any doubts there? You can ask me. Students, if you have any doubt related to the correlation, you can ask me. Otherwise, we'll move to regression analysis.
Ma'am, you can proceed, ma'am.
Yes, ma'am. Okay, ma'am.
Thank you, ma'am.
Okay, thank you. The next one is a regression analysis. Correlation and regression analysis have some relationship. Okay, correlation analysis, we have a two variables. Here also we have to use more two variable or more than two variables. Correlation, we have to find out the relationship. Okay, x variable and y variable. Here also we can consider x variable and y variable, but here we have to consider one is an independent variable, another one is a dependent variable. But in correlation, both must be independent variable. Okay, both variables should be independent variable, then only it's possible to apply the correlation analysis. Okay, so correlation analysis, we require two independent variable, but here also we are using a two independent variable, one independent variable and one dependent variable. That is called as a regression analysis. Regression analysis is nothing but to find out the relationship between the average value of the two variables is called as a regression analysis. Okay, for example, you have a past 5 years data is there. Okay, past 5 years data is there. Next 5 years you want to find out. Okay, that like that. For example, in COVID after 2025. Okay, how the COVID rate, it will increase. The cases will be increased or the cases will be decreased. Like this, you want to identify means you can use the past data and predict the future value. That is called as a regression analysis. Okay, using the past data to predict the future value is called as a regression analysis. The average relationship between the two variables are called as a regression analysis. Okay, in the regression analysis, you want to identify two variables. One is independent variable and another one is a dependent variable. So without independent variable or without dependent variable, it is not possible to apply. Okay, for example, some patients are affected for COVID-19. You want to identify what are the variables are influencing food habits. Okay, or their habit some habits, or they are smoking, or they are alcoholic person, that variables are affecting for the cancer. Okay, you want to what are the variables are influencing. Okay, what are the variables are influencing with a particular variable. If you want to identify like the situation, we have to use this regression analysis. Okay, you know that what is meant by independent and dependent variable. Anyway, one more time I am telling, one variable is not affecting to the other variable is called as a independent variable, and another one is called as a dependent variable. For example, I told height and weight, right? Height is an independent variable, weight is an independent variable. So height and weight I have means I have to calculate the correlation. Okay, now height, weight, BMI is there. How to calculate the BMI? How to calculate the BMI? If you have a height and weight value, then only possible to do the BMI calculation. Yes or no? Okay. So BMI, if you want to identify, you want height and weight. So BMI is a dependent variable. Height and weight is called as an independent variable. Are you clear? Height and weight is an independent variable. BMI is a dependent variable, because if you have the value of the height and weight, then only it's possible to calculate the BMI. Okay, this is an example for independent and dependent variable. So, what are the methods on there in regression analysis? Also, we have a same thing: graphical method and algebraic method is there. So graphical method is like how we are scattered that scatter diagram. No, what is diagram? So perfect positive correlation. So perfect positive correlation is an example for the graphical method. You can see here the data x value and y value. Whenever you have x and y value, you just draw the diagram, then you will get one diagram. That's all. You don't see whether it is a highly positive correlation or highly negative correlation, not like that. You just want to the diagram, you just consider dependent variable is a y axis and independent variable as a x axis. Based on that, you have to draw the diagram. That's all. It's like a scatter diagram. That's all. And the second model is a algebraic model. Algebraic model means we have to, with the help of the formula, we want to identify that. Okay, so regression line having a two lines is there. Okay, what does that line means? One is called as a regression line x on y. X on y. Another y is y on x. So we have a two regression lines are there. So what is the meaning we are using a two regression line means? That time we can consider x is a dependent variable, y is a independent variable. Okay, x is a dependent variable, y is a independent variable. So like the situation, I have to apply the x on y regression line when I have a y is a dependent variable and the x is a independent variable. Like the situation, I have to use the y on x regression line. Okay, these two lines are called as a regression line. That means I want to predict the y value with the help of the x. Sorry, I want to predict the x value with the help of the y is called as a x on y regression line. I want to predict the y variable with the help of the x variable means it is called as a y on x. Okay, so just you have to check your predictor variable. Based on that, you have to identify your regression lines. Okay, so before going to that, we want to study the types of regression line. Okay, so we have a two types of regression lines are there. One is a simple regression and another one is a multiple regression. I hope you remember the simple correlation and multiple correlation, right? The same concept here also. When I have only one independent variable, only one dependent variable is there. Okay, only one independent variable, only one dependent variable is there. It is called as a simple regression. It is called as a simple regression. When I have more than two independent variables there, more than two dependent variables there, it is called as a multiple regression. Okay, so that is a meaning for simple and multiple regression. So whatever it may be, either simple correlation or simple regression or multiple regression, you have to check both are quantitative. Okay, both are quantitative, continuous and normally distributed. These three conditions are satisfied only, then we go for the linear regression. regression analysis. If you have a not normally distributed means we have to apply some non-linear function. Okay, that is not there in your syllabus. Okay, so you have to check whether your data is continuous, normally distributed and quantitative. So the three conditions are satisfied, then you can go for the regression analysis. Okay. Now, what is the formula for x on y and y on x form, regression line? So first, when we are taking the x on y regression line, we can give the importance for x on y. So it starts with the x, right? So you can give the importance for x minus x bar is equal to coefficient of xy. That means p of xy into y minus y bar. So when you have a y value, we can possible to predict the x term. Okay. The next formula you just see the line of regression of y on x. So you can give the importance for y minus y bar is equal to byx of, okay, byx of, that's the coefficient of x minus x bar. Okay, so y minus y bar is equal to byx of x minus x bar. So you can always remember when the predictor variable is x, it starts with x only. When the predictor variable y, it is called as a y on x and it starts with y. Okay, this is the formula for two regression lines. And next one is the that formula. I don't know byx and bxy. That is why here I mentioned that. What is mean byx and what is mean bxy. Okay. Then based on this coefficient also we can possible to find out the correlation. Then what is the meaning of bxy meaning and byx? That explanation only I gave in this slide. Okay, this is the meaning. We have to use this word. When you are using this byx, you can use this formula. So when you have a byx coefficient you want to find out, instead of this, okay, then you can use this formula for predicting that variable. Just a formula explanation purpose I gave this slide. Then next one is the properties of regression coefficient. Sorry, properties of regression coefficient. You just listen the three things. Okay, one is what condition is important when your data are quantitative, normally distributed. Okay, then is possible. Second one, the regression value bxy and byx we have studied, right? Bxy and byx, that one value is greater than 1, another value must be less than 1. Okay, bxy I get 0.98. Okay, then byx I will get 1.25, like that way. So I have to verify one is greater than and another one is less than. Okay, that I want to identify. We cannot get both are equal or both are negative or both are positive, like that way we cannot get. So one coefficient value you will get a high value and another one will get a low value. So we want to identify that fluctuations. Okay, this is coming like this. So we are going to the proper way for the calculation that you want to identify. And the second one, in a study you should have one independent variable and one dependent variable. You have to verify that. Okay, then that independent variable, okay, when you want to change the origin, okay, that is possible. The origin is possible, but the scale is not possible. Okay, when we have to draw the diagram, that is the third one. Okay, and both the regression coefficients have the same sign, bxy, byx. The b is constant coefficient term. B is constant coefficient term. Xy and yx, that is only different. But the coefficient is beta, that will not change. The coefficient is beta, that will not change. So for both, it is beta is the same thing. Okay. And next one is a least square method. Least square method is called as a x on y regression and y on regression. You are studied, no? That is the same concept only we have to use. But here we have to use method of least square. We have to use years. Okay, when you say time based. Okay, time based. That is a chronological. Okay, when your data is a chronological type, that is a time based, year, month, second, minutes, like that way your data set is there. Okay, that means x variable, dependent variable, always time based. Y is a independent. Okay, x is a always time based. Okay, y is a independent variable, like that is there. That time we have to apply the uh, method of least square. This is called as a best fit model. Okay, y means whenever you are drawing this, definitely we will get only the linear function. Non-linear function we cannot get. Whenever you draw, we can get the values are moved to downwards to upward with the straight line. So that is the reason it is called as a least square method or best fit model. Okay. So here also we are going to study two things. One is a linear least square method and non-linear least square method. Non-linear is not there in your syllabus. So we are going to study only the linear model. Linear model is also called as a fitting of a straight line. That is called as y is equal to a plus bx is a formula. So in this one you have to check y is a dependent variable. Okay, this is a formula for linear least square method or fitting a straight line. Okay, so from this formula what we are observe means y is a dependent variable, sorry, y is a independent variable, a is a dependent variable, and b are constant, sorry, a and b are constant. Okay, that will not change. Okay, a and b are constant. Okay, then x is a x is a dependent variable and y is an independent variable. So based on that we have to solve these two equations. Okay, so when you solve these two equations we will get the constant a and b. Okay, summation y is equal to na plus b into summation y, and summation xy is equal to a into summation x plus b into summation y. So whenever we have a data set, okay, so in the problem they will mention x value and y value. They are already given in the problem. So with the help of that you have to find out x square column, y square column and axy. So if you completed this table, we get the results of summation x, summation y, summation xy, summation x square. So once you get the total, you just apply this equation and you will get the a and b value. Constant value you will get. So based on that, you can try to solve this term y is equal to a plus bx. So this is also one of the method of regression analysis. Sorry. Now, anyone tell me what is the difference between the correlation and regression? Till now we are studied. No. Anyone tell me what is the difference between the correlation and regression? The first point, the correlation is finding the relationship between the two independent variable. Regression is finding the average relationship between the one independent variable and one dependent variable. Okay, that is the first difference. And second difference is the range of correlation is -1 to +1. The range of regression is one is more than one means another one is a less than one. That is the second one. And third one, origin and scale is possible to change in the correlation, but origin scale is not possible to change in regression analysis. Okay, so the fourth one is most important one is you need to find out two variables. Okay, when you want to find out the correlation, we need two variables. But when you want to find out the regression, we want to identify one variable is based on the another variable. For example, I don't know height, weight, BMI, so like that. So height, weight is an independent variable, BMI is a dependent variable. So like that is we need it. Okay, these are the some of the difference between the correlation and regression analysis. And the most important one is a standard error of estimation. What is mean by standard error? You know the standard deviation, right? The standard deviation of a sample statistic, okay, standard deviation of the sample statistic, okay, based on the population parameter is called as a standard deviation. Okay, that formula is sigma by root n. Okay, that formula is sigma by root n. This concept, when you are applied in the regression analysis, this concept when you are applying in the regression analysis, it is called as a standard error of estimation. Okay, standard error of estimation. Why we are studying this standard error of estimation means you want to find out the accuracy. Okay, this is a prediction model, right? So we want to identify the accuracy level. So that is the reason we are studying this standard error of estimation. This formula is SEE is equal to root of summation yi minus y bar I the whole square divided by n minus k minus 1. N is number of trial or number of observation. K means how many observation you are selected for the predicting variable, and minus 1. So this is a formula explanation. Okay. N means number of observation or sample size. Minus k is how many variable you are considered for the predicting variable is considered as k. So like that we can consider, and if you are substitute means we'll get the standard error of estimate. And okay, I'm identified the regression value. Okay, so today many statistical softwares are there. Okay, I'm using that software and I'm calculating the standard error value, or I'm calculating the regression value. So like that time I want to see the R square value. So based on the R square value only we have to write the interpretation of the problem. Okay, so R is different, R square is different. Okay, R means correlation, R square means based on the SEE. Okay, based on the SEE, they are identifying the R square value. Okay, so if you want to find out the R square value, you can use the formula of SEE. Okay, so this range is called as 0 to 1. So it is similar to the probability range. Okay, so probability range also 0 to 1, and this also 0 to 1. You just remember. Okay, now you just see whenever your R square value is 0, the model is not effective. The model is not fit. That is the meaning. When your R square value is 1, the model is good fit. That means very good. It's very validated. That means it's very good fit. Okay, for example, okay, I solved one problem, then I used SEC formula. Based on the SEC formula, I calculated the R square, then I received the value 0.75. Okay, that means what? 75% of the variability in the dependent variable can be explained by the independent variable. So that particular term is influencing to the dependent variable. Okay, if you have a dependent predictor variable and the factors are there, means the dependent variable how influencing you want to check, that time we have to check this value. So R square is 0.75. Okay, for example, it is nearby 1. Okay, it is nearby 1. So we have to say the model is good fit. Okay, the model is good fit. If you are not known anything, you just see 0.75. 0.75, it is nearby 1. Okay, nearby 1 means the model is good fit. Okay, so based on the result, we have to mention that commands. Okay, under the problem we need to mention the command. And the last one is regression towards the mean. Okay, regression towards the mean. What is the regression formula? Did you see that formula? What is the regression formula? Did you remember? Regression formula is see this. So regression formula, if you have a two concept is there, x minus x bar is equal to r into sigma x by sigma y or y minus y bar. Okay, or y minus y bar is equal to r into sigma x by sigma y by sigma x into x minus x bar. Okay, here two corrections are there. One second. Sigma, this is sigma y by, okay, sigma y by x minus x bar. Okay, now you can see wherever you are calculating the regression, the mean is most important. X bar means the mean of x independent variable. Okay, x bar means what is the formula mean? That is equal to summation xi by n. Xi by n. So based on the population only we are predicting this mean value. Then our observation based. So y bar is equal to summation yi by n. So this is a formula, right? So regression about the mean means with the help of the mean only we are doing the regression on x on y and regression on y on x term. Okay, so you just give more important for this mean value. That is a meaning for that. The last slide. Sorry. Just see that towards the mean. So the mean is most important. So based on the mean value only we are going to the next calculations and all. So you just give more important for regression analysis. Okay. Now we will discuss the problem based on the correlation. Then that is the final thing. Once we complete it, we'll wind up the class. The Word document is visible.
Yes, ma'am, it is visible.
Okay.
Yes, ma'am.
See the problem. Example, calculate the correlation coefficient between the height of father and son. So in the problem, they are mentioned the father height and son height. They want to identify any relationship is there between these two variables. Okay. Now you just see the formula. Okay. So already I gave two formulas, right? Do you remember? So summation x minus x bar into summation y minus y bar divided by root of summation x minus x bar the whole squared into summation y minus y bar the whole squared. Okay, for correlation we have totally 9 formulas are there. You can use any one of that formula. Okay, this is one of the formula for that. Now x value we can consider father age is x and we can consider son height is father height is x and son height is y. Okay, now x is a father height, right? So first x value is you have to consider one column, and y son age height is you can consider as a y column. Okay, first you can add that column value. Okay, so if you are adding this value, we'll get 469. That is the total of summation x. Okay, and if you are adding the son height, it is 476. That is you can consider summation y. Now you get the summation x and summation y, right? So you can apply the mean formula. What is the mean formula? X bar is equal to summation xi by n. So how many observations are there? 2, 4, 6, 1, 7. So totally 7 father and 7 son details are there. So n is equal to 7. Okay. So n is equal to 7. Then here also n is equal to 7. Okay. So what is the total of summation x? 469. Then 467 divided by 7. If you applied in the x bar formula, we get 67. So the average height of father is 67. So like that way you can find out the son heights also. Okay. So what the total of son heights? That is 476. So 476 divided by 7, we get the average son height is 68. So you once you find out the once you find out the average means you can substitute in the formula. Okay, so x minus x bar. Okay, so 64. This means x values are here 64. What is the average? 67. 64 minus 67. Okay, so then you will get that answer. 64 minus 67 minus 3, 65 minus 67 minus 2, 66 minus 67 minus 1. So like that way you can find this column. Okay, once you find out this column, you just square that column. Okay, 3 square is minus 3 square is plus 9. Okay, minus 2 square is plus 4. Minus 1 square is 1. 0 square is 1. Like that way you can find out this column. So once further calculation is over, okay, these are the father's informations, right? So father's calculation is over. You can add the total. That is summation xi minus x bar the whole square is equal to 28. Okay, so like the same way you can find the son informations also. So here y minus y bar means what is the y bar answer? 68. So apply the 68. Okay, so 68 means 66 minus 68 minus 2, then 67 minus 68 minus 1, 65 minus 68 minus 3, 68 minus 68 0, 70 minus 68 plus 2, 68 minus 68 0, 72 minus 68 is 4. So like this way you can find out. Once you completed the same, you can square that. Minus 2 is plus 4, minus 1 is plus 1, minus 3 is 9, 0 square is 0, 2 square is 4, 0 square is 0, 4 square is 16. Then sun in calculation is over, then you can add the column, then we'll get the answer 34. Okay, once you've done that, okay, see the formula. Okay, see the formula, we get the denominator value we got, but we want to find out the numerator. Summation x minus x bar into summation x minus x bar into y minus y bar. So now we want to multiply these two columns. Now we want to multiply these two columns, then that we have to mention in the last column. Okay, so 3 minus 3 into minus 2 plus 6, minus 2 into minus 1 plus 2, minus 1 into minus 3 plus 3, 0 into 0 0, 1 into 2 2, 2 into 0 0, 3 into 4 12. So once you done these things, okay, you can add the last column also, we can get 25. Okay, now these three values are most important. Okay, one is this answer and another one is this answer and last one is this answer. So from this table we want to find out, so we will consider only these three value. Okay, now you can see summation x minus x bar into y minus y bar, that is a column, last column value, that is 25. Okay, 25 divided by numerator value is 25 divided by square root of, okay, square root of, okay, what is that? Summation xy minus x bar the whole square, that is 28 into, okay, summation y minus y bar is 34. Just substitute the formula, then you will get the results. See these steps, 25 divided by root of 28 into 34. The same thing, whatever I wrote here, no, the same thing I explained with fraction here. R is equal to 25 by root of 28 into 34. Then We'll get numerator you can keep, then multiply the denominator 28 into 34, that is 952. Then take out of root, it will 30.85. Finally, you can divide 25 divided by 30.85. We will get the answer R is equal to 0.81. So 0.81 is lies. It is lies 0 to plus 1. Did you remember the types of correlation? Okay, so this 0.81 is lies 0 to plus 1. So it is called as a highly positive correlation. It is called as a highly positive correlation. Are you clear? Do you have any doubt in this problem?
No, ma'am.
Okay,
Ma'am.
okay. Okay, that's all. Thank you for patiently attending this class. I hope you understand. If you have any doubt, now you can ask me.
Ma'am, I have a doubt, ma'am.
Yes, ma'am.
Ma'am, whether we are proceeding with regression means we are applying through real-time examples like stock market predictions as well as stock price prediction. Mean whether we can apply regression in there, ma'am.
Yes, yes. You want to predict the variables, okay? What are the variables are influencing to the particular thing? If you want to identify, definitely regression only possible to apply, ma'am.
Whether the value accuracy will be in high range or else it will be
No
deviation
problem,
from
no
normal, ma'am.
problem. That you just see in the real world data whenever we are taking, okay, don't bother about the answer. We have to check. That is a research. We have to verify whether that model is suitable or not. That's all. So as per our research, that is not that model is not fit. That's all. So better you have to take good data set. So whenever you are seeing screening data is important here. So whenever you are taking a real data set, screening data is important. So you have to check each and every information. Okay, for example, one company information you are taking, you have to verify it's gradually increasing or gradually decreasing, how it was going, like that criteria you have to check. So based on that you have to choose your data, then screen your data, check missing data is less than 10 percentage, this everything will increase your modeling fit. So this and all if you are not take caring, definitely the model value will decrease more.
Okay, ma'am. Is there any other methods for handling the forecasting models, ma'am?
Any other methods you are asking, huh?
Yeah, yes, ma'am.
Yeah, that is ARIMA model is there, predicting ARIMA model or time series analysis. Then many models are there in time series, stochastic process. That and all, when your data is time based, then you can go for ARIMA model. If it is
Yeah,
not,
okay.
you can use Bayesian regression analysis. Okay, otherwise your data are categorical, you can use Bayesian logistic regression. Instead of if you are using the frequency method, you just apply some machine learning concept, Bayesian concept you can apply. Definitely you will get better results.
Yeah, okay, ma'am. Thanks, ma'am.
Okay. Students, do you have any doubts? Payuri ma'am?
Yes, ma'am.
Ma'am, if any students, they are not asking any doubts, ma'am.
Hope all are clear, ma'am.
Okay, okay, ma'am. Yes, ma'am.
Visha,
Yes, ma'am. Thank you, ma'am, for delivering such an insightful and enriching session on exploring data analytics using statistical methods. Your expertise and clear explanations have greatly enhanced our understanding of the subject. We appreciate the time and effort you have put into sharing your knowledge with us. It has been a valuable learning experience for everyone. Thank you once again. Thank you, ma'am. Thank you so much, ma'am.
Thank you, ma'am. Thank you, Divisha, and thank you, Pangudi, ma'am. I hope students are understand these things. Okay, if you have any doubt, okay, definitely feel free and contact me. Okay, now my mail id is dr.j.vanilla@gmail.com. Okay, you just put a mail. I'm clear. Definitely I will clear your doubts. Okay, I hope you understand this section. Okay, thank you for all. Pangudi ma'am, thank you.
Thank you, ma'am. Thank you. We will discuss.